Hello and welcome. My name is Denis Dublineau. I'm working as a pre-sales consultant in the PTC Arbortext team. I'm based in Europe, more precisely in France. Today I will be presenting how our PTC Arbortext solution is uniquely positioned to help industrial companies to produce product-centric technical publications while maintaining the digital thread along the product lifecycle. The PTC Arbortext solution is a complete suite and probably the most comprehensive suite of software tools, which is covering the end-to-end technical publication process. For content creation, users can leverage the pre-existing product information like bill of materials and CAD models to produce illustrations, 2D illustrations, or static or animated 3D illustrations. They can also author XML content or even HTML content, which is still used in some verticals. And they can define the spare parts offering and produce the spare parts catalog. All this content may be managed, of course, and users can benefit from advanced content management capabilities, including the management of the translation process. And as we will see, those capabilities is particularly relevant for technical documents which are related to industrial products. For delivering the technical information, we have publishing technologies that will be presented in the next session. The publishing technologies can produce page-oriented deliverables like PDF or printed material. It can, of course, produce also electronic versions of the documents. And we can also offer a document and parts catalog portal where field technicians may access to the product information, the maintenance information, and where they can look for the spare parts and order the spare parts. And the technical information may also be made available through IoT applications and augmented reality experiences. It makes a fully integrated solution, but it shall be remembered that any of the components of the complete production chain can be used independently of the others. So it's possible to use one of these tools even if the other tools are not used. PTC is well positioned to build and propose such a comprehensive one-stop shopping TechPubs solution. We have a long experience with structured modular documentation technologies coming from the Arbortext company, which was a pioneer in developing HTML, XML, and publishing applications and tools. Today, our editing tool, the Arbortext editor, is used by something like 40,000 users in the world. But at the same time, PTC is also a leader in CAD technologies with the Creo family of products. So we know how to manipulate 3D models, 3D information. PTC is also a leader in the PLM market, the product lifecycle management systems market, with the windshield technology. PLM systems manage product data in configuration along the product lifecycle. So we are leveraging those capabilities initially designed for product information to manage the documentation in configuration and concurrently with the product information. That's what we will be showing today. PTC is also investing a lot and is now becoming a leader for industrial IoT, the Internet of Things, with the ThingWorx products, which are used to interconnect the products, the people, and the databases. So it's a way for giving access to information in the context of product when it is used and running. We also have a well-recognized augmented reality solution, which is called Vuforia. So again, by interconnecting Vuforia with ThingWorks, with our document portals, we have ways for providing an integrated experience to the field users for accessing in a smooth way product information, service information, and having a very good environment for working and maintaining the products. On this slide, you can see the names of the software products used in the PTC Arbortext solution. Today, we will be focusing on the authoring tool and the management tools. We will be using Arbortext Editor, Creo Illustrate, and Windshield Service Parts Information and Instructions. Service Parts Information and Instructions is built on top of the Windshield technology. It provides XML content management capabilities and parts catalog authoring features. From the beginning of this talk, I'm talking about the digital thread. So what is it exactly? If you consider the industrial process and the product lifecycle, you understand that there are several steps. The product must be designed, it must be specified, must be manufactured, and someone needs to define how to build and manufacture the product. The same way someone needs to define how the product will be maintained in the future. At the end of that process, the product is distributed and used and maintained. At each step, there are teams of people who are working and creating information based on the information coming from the other steps, the upfront steps. The purpose of the digital thread is really to maintain the digital continuity between those steps and between the teams working on the product lifecycle. So it means that it shall be easy for someone to find the source information needed to do the job and to produce new information. And at each point in time, it should be possible to find where the source of a given information is and to check if that source information was updated or not in order to take a possible change or modification into account to make sure that it will be forwarded downstream to the next teams and next steps of the process. Thanks to the Arbortext solution, we will make sure that the people who are preparing the technical or service information will have a direct access to the source product definition data, and that the links between the information which is created and the source information are kept over time so that it will be easy to make the impact analysis if something is changed upfront, and it will be quick to update the service and technical information after such changes. However, the situation we all know in industrial companies is that each team is more or less working in silos for historical, organizational, and technical reasons. Each team selected the best tool for performing their own tasks, but the tools cannot communicate and share information with the other tools. The result is a lot of time and energy spent trying to find the required source information and to make sure that what was created and done in the past is still valid. For example, if some changes were made by other teams on the product definition. And the most negative consequence is once the product and the documentation have been delivered to the end users, very often they are not really in sync. The technical information is not reflecting exactly what the product is. And of course, this is creating a lot of trouble for the field people, the users, the people maintaining the product. The technology we are proposing is enabling to implement the best possible situation where everyone in the process will be sharing the same reference information in a single repository. So no need to search or to wait for information coming from somewhere else. No need to duplicate information in multiple silos. The reference information everyone is needing is available at fingertips. In practice, this means that the various teams are really working together. They are sharing a common data set, a common working environment, and a common understanding of the current state of the product development. And this is very important because it is facilitating the communication between the teams if they are working in the same environment and not working with multiple disconnected tools which may have different data models, different technologies. Um, Having the same working environment is really a key for the internal communication. Also, the illustrations, which will directly based on and linked to the source CADs, the documents authored will be linked to the assemblies of the product definition in the bill of materials. It will be possible to make a product-centric configuration management for the documentation, to use the actual product options to filter and define the applicability of the documents. And for the parts catalog authoring, it will not be a duplication of information in a document. The parts catalog authoring will be done directly by manipulating the parts themselves. And so by definition, the product catalog will contain the actual parts attributes and part information. So have a look at what it means to be sharing a common repository of information. When you access to windshield service parts information and instructions using your web browser, you have access to your home page where you can see your subscriptions and the tasks you have to perform, and the list of the latest documents you modified, and also the list of the objects that you have checked out to modify them, like the parts list or the XML components. The information in Windshield is organized according to containers, which are generally product containers. So it's a way for grouping all the information related to a product in a given container. And for example, here I have an information structure, which is a way for organizing all the modules of information, all the components, the parts list which are related to a specific product. I have access to the metadata about the objects, their lifecycle state, their version, and for XML components, I may have a quick look at the XML content of the components. But although I'm a technical author here, I can also access to the product definition and to the product structure. I mean the bill of material with, on the right, the associated digital markup. And it's very important because that way I have a direct access at the visualization of the product, even if it has not yet been manufactured. And I can identify all the parts and assemblies of the products. I can see how they look like. I can manipulate them, access to the details, and better understand how the product is made and defined. So if I go to the details of the engine, I can select a part, see where it is, how it looks like. It doesn't mean that everyone can do anything. For each product, you define a team and with roles. So someone is allocated to a role, and what we will be allowed to do in the system on the objects is depending on the role. Here we can define for that specific product which are the actions the end user is allowed to do. That way we can make sure that technical authors will be able to view the product and the product definitions, but will not be allowed to modify anything in the product definition. Now let's see how we can link the document objects to the product. Here I'm back in the information structure, which is some kind of data map, which is directly accessible from the windshield user interface. From this structure, I can access to my XML component. And for example, I can open one of these components in Arbortext editor and see the content. From within Arbortext editor, I have access to the content of my server, and so I can create the cross references between topics. I can insert images and relate to other components stored in the database. I can also, of course, insert new, create new components. Let's say I want to create a new XML document. I can select the type of objects I want to create. I can select the authoring language. So let's say I want to create something in English, and I have several templates available to me depending on the type of component or DTD I want to be using. And I can enter the title and or the information about my document. I now have my new document. And what I can do as a technical author is to create an association, a link between my document objects and the parts or assemblies from the bill of material of the product I'm working on. Using this link from here, I can access to the component itself, and I can visualize it and understand, again, how it is made. But this link is very important for doing the impact analysis in case of a change. So, for example, if the design office or the managers of the product are deciding to make a change and to analyze the impact of that change on the product and on the information about the product, they can, let's say, create a change request. So they can give it a name and provide information about the change. And then they will be assisted to identify which are the objects which are impacted by this component. So here, for example, I can search for all the parts lists or the document components which are related to this object, and typically here I see that 2 parts lists are containing this part and 2 documents are referring to this part. So I can include these objects into the change request or the change notice. Let's look at what's happening with CAD-based illustrations. I have a topic. Let's look at the details of the topic. I can see, the structure, so I can see the subcomponents the topic may be using, and I can see there is an illustration, so I can go to the details of this illustration and see that this illustration is coming from a illustration source. This is a 3D illustration, and from here I can see on which source information this 3D illustration is based on. So this object is a 3D representation which has been automatically generated from the CAD models and which has been imported into our illustration file. And interestingly, I can see these symbols which tells me that my illustration is not really up to date to the source information. So the 3D representation is currently in A3 version, while my illustration was based on the A1. If I open my illustration in the editing tool, CreoIllustrate, when the illustration file is opened, the system is warning me that something has changed in the source information, and it will update my illustration accordingly. So typically, if some parts were removed from the assembly, they will disappear from my illustration. If new parts have been added to the assembly, they will appear at their default position. In this illustration file, I have several views which have been created, so we can have a quick look at the kind of representation we can create with the editing tool. So I can create exploded views and add the explode lines and the callouts. I can create details view, and I can create sections and very easily adjust my sections. I can use phantom modes and create animations. Or animated sequences where I can define step-by-step, or I can illustrate step-by-step sequences. Document content configuration management. The design engineers may define the options the product will support. We know that modern products can be heavily personalized by the customers. It means that there are many variants that may be created for the products. The design engineers can specify all the possible options and the possible values the product will support. These options will be used by the design engineers to create an overloaded product structure. So for example, here I have two engines in my car, two variants for the engine, and they have defined the applicability on each of the variant. And of course, the system can filter the structure, the product structure. So if I want to see the product with only the PX2 engine, I can define the filter and only this assembly will appear in the product structure. So we will be able to do exactly the same with the information structure and the document definition. Here we are looking at our information structure containing topics, XML topics and parts list, and we can see that some applicability have been set on the objects. To define the applicability on a topic, you have access to the exact same applicability options as the one used in the product structure. The options which were defined by the design engineers. So the document authoring environment is not using a different kind of profiling mechanism. It is exactly the technical options which may be used for defining the applicability. In some industries, the applicability may be very complex if you think to the automobile industry. So it will be possible here to assign advanced expression for defining the applicability, where you can mix any combination of options using the and, the or, the not operator, and combining all this using parentheses. The system will validate the formula, the expression which has been entered to make sure that it is valid. You can also define effectivity for the topics. It can be serial number ranges, or it can be dates effectivity, where you specify a range of dates which may be corresponding to manufacturing dates. In the case, the application in the topic is only valid for the cars which have been manufactured between date A and date B. So we support serial number applicability, effectivity, and date effectivity, but the system can be expanded to use other kinds of information for defining a very precise effectivity to the content. Of course, when publishing your publications, you will be able to set a filter which will allow you to publish the content for a specific product configuration. Now let's see how to produce an associative spare parts catalog. The process for creating a spare parts catalog is always the same. The first step is really to define what parts will be sold as spares to the end customers. So in our context, it means that we will define a spares BOM from the engineering or the manufacturing upfront BOMs. During this transformation, we will decide exactly what will be sold. Then when we know what the spares are, we can create the parts lists, and which is a way of grouping the parts together so that they will be illustrated together and published together in the final documentation. When we know what the parts are in each parts list, we can create the illustration for the parts list. Here, the creation of the illustration will be done automatically just because the system knows the parts in the parts list, and he knows the CAD definitions for each of the parts, so the system can aggregate all the 3D representations for the parts and produce the illustration. And the users will just have to make the illustration nice, but the creation of the callouts and the positioning of the parts will be automatically generated by the system. And eventually we'll have parts lists which can be used in our publication structures or information structures. So again, these are some kinds of data maps managed by the database, and eventually they will be published. The big difference with the traditional process here is that for all those initial steps, we are not duplicating information. So we are not using a text processing tool or a different database for managing the information of the parts catalog. The system will work directly with the parts objects and the parts definitions, and that information will be transformed as documents only at the last step when the information is published. Regarding the first step in the process, so the definition of the spares offering, there are many reasons why you cannot use exactly the parts as defined in the main initial bill of material. The spares which are sold may be of a different granularity as the one defined in the source BOM. You may sell assembled components and not just all the small pieces which are in the assembly. You may want to create kits. Some parts may not be available as spares, and sometimes even if the same part, physical part, is sold, it shall have a different part number because it's coming from a different provider than the one used for manufacturing initially the product. So it means that most of the time you have to do a transformation on the BOMs in order to define what exactly will be spares. The trick here is that this is done in the system, and of course the system will know the relationship between the spare and the engineering or manufacturing part it is based on or derived from. Here I'm looking at the source bill of material, and I will open a tool which will allow me to define the spares bill of material. And I can see that some spares have been defined and that I have a symbol here which tells me if my spare is up to date compared to the source part. And I can use the tool to update the information. So if some attributes or the applicability of the part was modified, the change will be applied to my spare definition. Here, what I will do is to create a new spare because I see that the source bill of material was modified and a new shifter was created for a new configuration of my product. So I just have to copy the part from the left and to paste it on the right, and I can paste it as a new part, meaning that I will be able to define a new part number if it is different from the original one. And as you can see, the applicability on the parts is automatically inherited and applied to the corresponding spare. I see that some parts are defined as kits, and will be processed as such downstream in the parts catalog. At any moment I can have a look at the visual representation of the part, and here I can see that which part have been consumed from the left and used as spares, so I cannot forget any part in that transformation. So now I have my spares bill of material, and from here I will generate the parts lists based on the tree structure of the bill of material. So I will have my new parts list, and I can put them into the publication structures or information structures. And I have signs which are telling me if my parts lists are up to date, and if they are not, I have tools which will show me what the difference between the current status of the parts list and the status of the spares bill of materials. So I can easily update the parts list with the changes made upfront in the bill of material. Here a new part was added, so all what I have to do is to update the illustration, and as you will see, the new part, the new shifter, is automatically added to the existing illustration, which is untouched. So I have the exploded view with the callouts. So all what I have to do is to decide where I will position my new part in the illustration, and the update is done. So it's very quick. You cannot forget to take the update into account, and the information may be made up to date very, very quickly. Then you can publish the information, publish the parts list or the complete set of information. When doing the publishing, you can select the languages you want the publication to be made in, and that's it. We've made a quick tour of the features available in the Arbortext solution, which are more specifically dedicated to creating technical information for documenting technical and industrial products. Of course, there are many more features available in the system, like the translation management. So to summarize what we've seen that teams from different groups can work on the same data set without any duplication during the full life cycle of the product. We've seen that the illustrations were based on the source CAD, so that people could be informed if the CAD was modified and could integrate the modification very quickly in the illustrations. Similarly, the textual documents and the structures of the publications can be linked to the assemblies of the bill of material, so that they are easily identified during the impact analysis for the engineering changes. The configuration management may rely on the same criteria and the same options definitions as the one used for the product itself. And the parts catalog is created by using the parts and the native part information, so that all the modifications can be identified and taken into account very, very quickly. Of course, we've been looking to the ideal situation where really everyone could be working on the same system. There are situations where the company is already using a PLM system for engineering information, and let's say an ERP system for managing the manufacturing information, and they will not easily replace those systems. In such situation, it may still be a good idea of using the solution we are proposing, where the parts catalog and the technical authoring can be done in the same environment, where product definition information can be replicated to serve as source information for those people. In the technology we are proposing, there are several interfaces and interfacing solutions available using our technology or the technology of several partners to interconnect the system with the legacy or existing systems in the company, meaning the PLM or the ERP. So depending on the level of integration which is expected from the simple import of files or situations where automatically any change in the upfront systems will be synchronized automatically in the service authoring environment. There is a solution available for synchronizing information and making sure that people in charge of technical documentation and parts catalog can work properly and be very efficient. One last comment, the system I've been demonstrating is configured by default for supporting data content when talking about the XML authoring, but PTC with our partner named GPSL developed a configuration layer on top of Windchill and Arbortext for supporting the S1000D standard used in the aircraft and defense industry. So we have a complete solution, CSDB solution for S1000D, which is working and which can benefit from the features we've demonstrated today. So the S1000D CSDB can be merged, if I may say, with the product definitions. The last comment is that the solution I've demonstrated can be deployed on-premise by our customers, but we can, at PTC, we can also host completely the solution and offer some kind of SaaS solution for deploying the solution. Thank you for attending this presentation. Don't hesitate to contact me for technical details or to contact my colleague Regine Müller, who is attending to the fair. You can find additional information on the ptc.com website on the Arbortext pages. You can also go to our Arbortext YouTube channel, where many videos are available for describing our products, and you can connect to the PTC Arbortext community on the internet. Thanks again, and I hope to be able to meet you in person very soon. Take care.